the first thing you think of when you think of NASA? Space, right? But what else is NASA known for? Any clues, Johnny?
How about aeronautics? Yeah, NASA's testing and development of new technologies is one of the key missions for the agency.
That's right. The first A in NASA stands for aeronautics, and you better believe NASA takes its job of keeping the flying public safe very seriously. Hi, I'm Jennifer Pulley.
And I'm Johnny Alonzo, and today on NASA 360, we're going to find out a little more about how NASA engineers are paving the way to new aeronautical breakthroughs.
And we're also going to see how NASA is helping to make the future of flying safer and much greener, too. How about a little history lesson first? You know, NASA was formed back in 1958 with much of its energy going towards getting us into space. But as early as 1917, NASA's predecessor agency, NACA, or the National Advisory Committee for Aeronautics, was turning flight into a science. Over the years, NACA and NASA engineers worked really hard to make flying much safer and efficient. In fact, virtually every aircraft ever flown in the U.S. has in some way been tested by NASA. Those engineers back in the day probably had it much harder than the engineers do today. Wouldn't you say so, Johnny?
Yeah, that's right, Jen. Aircraft testing has definitely come a long way since the old days. I mean, one of the biggest changes ever has to be the invention of the computer.
Engineers today have so many more options available to them than the old guys, including gathering really precise data, using state-of-the-art computer graphics, networking abilities, and tons of other benefits too.
But guess what? Even with so much more technology available today, one thing still holds true. You still got to be able to build the aircraft and get it to fly at some point, right?
That's right, and obviously you don't want to build a full-scale aircraft until you have all the kinks worked out of the design. So what do? You build a scale model.
A scale model is an exact representation of an aircraft, just a lot smaller, of course. When engineers build these models, they can get really valuable information about how the full-scale aircraft will fly. One way to test the aircraft is the time-honored routine of putting it in a wind tunnel to check out its flight worthiness. Another way is to actually put small engines on the plane and fly it by remote control.
This type of initial testing is even more important when you're trying to break out of conventional designs and build an entirely new type of aircraft. And when I say new type of aircraft, I mean getting away from the traditional tube and wing design and really stretching the envelope to build the aircraft of tomorrow.
That's right. Now, Jen mentioned the traditional tube and wing design, which is basically used on every aircraft today. A tube with wings placed on each side. This design's been used for over 100 years because it's fairly efficient, it's easy to pressurize, and it's relatively quiet. But guess what? Researchers and engineers are discovering there might be a different design that can be more efficient, as safe if not safer than current aircraft, and much quieter too. Yeah, the new radical design called the blended wing body, or the BWB.
Now, one of the primary reasons this design looks so promising is that by blending the wings into a wide tailless body, you get additional lift with less drag. In plain English, that means the plane could be up to 30% more efficient and quieter than conventional planes. Okay, remember when we were talking about scale models earlier? Well, that's where the BWB program is right now. Researchers are testing two 8.5% scale models that have a 21-foot wingspan and weigh about 500 pounds. Testing is being performed in a couple of different ways. One of the models is being flown and validated at NASA Langley's full-scale wind tunnel with some very encouraging results.
But researchers also need to see this aircraft fly in the real world. And what better place to do it than where the sound barrier was first broken and so many other important air milestones were reached, right here at NASA Dryden in Edwards, California.
I caught up with a couple buddies to find out a little more about how flight testing for the BWB is conducted.
Hey,
how
Johnny.
you doing, man? Yeah, good to see you.
Hey, how you doing today?
How you been?
Good. Good to see you.
This is wicked, man. Tell me about this.
All right. Well, this is our scale model of a hybrid wing body flying aircraft. This is a 21-foot span scale version of a larger aircraft that we would fly. This program's been underway for about 4 years, and we've got this really fantastic team at NASA working with our industry partners from Boeing and Cranfield to do some low-speed flight testing.
Well, can you tell me some of the differences between this aircraft and the ones that we're flying today?
So this aircraft is it's a blended configuration. So we blend the wing and the fuselage in a way that it's more of an integrated configuration, and we do that.
See that?
Yeah, we do that to get us benefits in a couple of areas. First one is the aircraft is more efficient, so we get better fuel burn characteristics. What we call lift-to-drag ratio is much better. And the other thing we get with an aircraft like this that we're trying to prove out is we get better noise characteristics. And that will depend upon the engine placement, of course, and that's one of the things that we're trying to work on over time with this type of configuration.
Really?
So this aircraft gives us that 1-2 punch. Better fuel burn, better noise.
Nice. We've been working tube and wing for like 50 years, right? 50 plus. I mean, why innovate?
Yeah, so we think, it's just because of that reason. We've been working tube and wing for a long time. We've polished that configuration for a long, long time. We think we've probably gotten the best out of it that we can in terms of fuel burn and noise reduction. And as I was explaining to you earlier, this configuration, we think we can build and design such a thing to work both fuel burn and noise at the same time. So it's that simultaneous attainment of two very major and critical goals where we think a configuration like this can help us out.
Okay, so this is a scale model, obviously.
Right.
So if you built this up, I mean, will it look exactly the same?
Yeah, Johnny, this is an exact replica. It would scale up to have the same characteristics, same shape, same look as this scaled version. So one of the things we're trying to work on there, though, is the placement of the engines and the type of engines that we might use on it. So the engine location might be a little bit different.
I see this one's all mounted all the way towards the back.
Right. What we have here, these are potted engines. Okay. So that's one concept that we have that we're looking at. It's a lower risk idea.
Okay.
Potted means that it's sitting up off the airplane.
Okay.
Right. So you can see that it's mounted up, and there's some space between the body and the engine itself. There are a couple of other ideas floating around, like embedded engines, and they would be sunk down inside the airframe, and there would be little inlets to take the air needed to drive the propulsion system. So that's another idea that we're starting to explore in wind tunnel testing.
Really?
Yeah.
So obviously, this is in the testing phase. Where do you see this? I mean, how do you see this progressing?
Right. So Johnny, we're working with the Air Force. We're working with Boeing, R&T on this project, and this thing has a long. The vision for this is long range. So initially, we think it's probably a military application, cargo carrying application. And then maybe out 2030, 2035, we move on. Maybe it's commercial cargo, package carrying, and then maybe in the long run it becomes a passenger carrying aircraft. But that's way out in the future.
I would love to see this thing fly. I mean, is this R-seat? Is this remote controlled?
Yeah, what we decided to do here is use an unmanned approach. It's cheaper to do that in the get-go when you start out with a scale model. So it's unmanned, it's remotely piloted. We take the thing up, we fly for about 30 minutes from a trailer that goes along with the aircraft.
Really?
Yeah.
Let's check it out.
All right.
Let's go.
On this morning, Johnny and the crew were in for a treat because the X-48 flight test was flown out on one of the most famous test areas in the world, the 44 square mile dry lake beds out at NASA Dryden.
I show us lining up on the runway. Yep, you're looking real good.
Before the second flight of the day, Johnny went back to the remote piloting facility to meet up with Boeing test pilot Mike Cizo to see how the aircraft is flown.
Hey, I'm here with pilot Michael Cizo. Check this out. Hey, tell us exactly where we are.
We're in the ground control station, or GCS, where we remotely control the X-48 based on all these displays, and the full cockpit setup is here, so I have all the information necessary for flight and monitor all the parameters to stay airborne and safely land.
That's awesome. Are we ready to go?
Absolutely, we're ready to start the mission.
Let's go.
We're ready to launch on that 2-3 right. My clearance will take off and we'll call you airborne. Launch is ready. Power's coming in. Ready. Come on, look out. Good engines.
Sky road for airborne. Nice lift off.
10,000 and below. We're now passing 2,700. Switch over to sport. You can see this display shows my heads out view, and that's what the nose of the plane is seeing. And on this display here, that's my ground track coming up, and then that's actually the circle. The actual airplane is that little dot here where we are. That's an impact predictor that if we had to, if some unfortunate event happened, we had to terminate this remote control vehicle, that's where it would go.
Really?
With the flight path.
Is it me or is this thing moving?
It's interesting. It feels like it's moving. If you look at this and look outside, you feel like it's moving, but it's actually not. And that's one of the things that we have to deal with, is that there's no motion inside here, and we have to imagine what it'd be like on the airplane. Chase will be a right-hand turn, 180 at the rear. We're approaching 5,000 feet MSL now. Basically, our flights last about 30 to 35 minutes, so that's about how much time we have fuel for.
Yeah, fuel for.
Yeah, Chase, we're coming right now. Coming right now. Decent sun angle on the camera. Yeah.
So how long have you been flying as a pilot?
Over 20 years.
Right on.
So, Chase will be at the end of the area. It'll be a right-hand turn back. I look forward to actually being able to fly this airplane when it comes out full scale.
I'm sure you are.
My normal landing is speed brake position 1. I've set that up. We're running our before landing checks now. And I'm basically heading outbound, and I'll be starting a turn looking for the landing runway. Unfortunately, I don't have a 360-degree view like your name suggests, but what I'm doing is if I need any help, I'll use Chase, but actually having the view out the plane and also the God's eye view here.
Right, I'm watching that,
yep.
Right.
And we're going to be landing basically on the southern edge of the boundary, coming down for the landing point there.
Gotcha.
Then we actually do have an artificial, like an instrument landing system that helped me tell me whether I'm high or low on glide path or left or right of center line. And now I can see the runway that I'm going to be aiming for.
Yeah.
And eventually the markers will start coming in with the instrument landing.
5, 3, 2, 0.
Touchdown. That's awesome.
Brakes applied. And another flight of the X-48 complete.
Smooth landing.
Yeah.
Hey, this was a lot of fun.
Oh.
This is awesome. Thank you so much for your
You're
time.
welcome.
Quick question for you. How are automobiles tested to make sure they're safe? You crash test them, right? You've probably seen this before. Crash test dummies are placed into cars and then they're slammed into walls or other cars to be sure the car is safe. Well, believe it or not, NASA does crash testing, just not on cars.
There's a unique facility out at NASA Langley called the Landing Impact Research Facility, where this type of crash testing takes place. Tons of things have been crash tested out here over the years, including small general aviation aircraft and even next-generation spacecraft designs. But one of the most recent vehicles tested out here was an MD-500 helicopter. Think about it. Helicopters are being used quite a bit these days for air ambulances, traffic reports, police surveillance, and of course military uses. Although helicopters are extremely safe, according to federal crash statistics, they crash at a rate of about 3 times higher than other commercial aircraft.
Now, some major limitations of helicopters are that because they fly so close to the ground, they face many more obstacles. And of course, they can't glide like a fixed-winged aircraft can. This is where the testing at NASA comes in.
A unique accordion-shaped airbag called the Deployable Energy Absorber is being developed to help prevent passenger injuries in case of a hard landing or crashes. This accordion shape is interesting because it deploys like a traditional airbag, but it doesn't have some of the drawbacks seen in traditional airbags.
So think of an airbag like this balloon here. If you hit the ground like this, it offers lots of protection. But most crashes have an element of crush with shear, and a traditional airbag may not handle the shear very well.
NASA researchers believe that because this accordion-shaped structure is designed to take crush and shear loads from many different directions, the vehicle occupant's survivability chances would greatly improve. But to validate this belief, a crash test needed to be performed. So NASA borrowed an MD-500 helicopter from the Army, then equipped it with instruments to collect 160 channels of data from the craft and 4 crash test dummies. 3 of the dummies were standard crash test dummies, but the 4th was a special unit provided by Johns Hopkins University Applied Physics Lab that measured possible internal injuries of an occupant. So on the day of the test, NASA technicians outfitted the underside of the helicopter's crew and passenger compartment with a composite accordion-shaped structure. The helicopter was then suspended about 35 feet into the air and then released.
1, release.
So how did it turn out for the crash test dummies? Well, engineers say the helicopter and its passengers survived this severe crash relatively intact as a result of the deployable energy absorber. Engineers plan more tests soon to further validate this design.
If this idea is someday used in real-world conditions, it will almost certainly save lives. Of course, NASA engineers believe this technology could also be used in passenger cars. Okay, so we know NASA is working hard to make flying even safer than it is today, but there's still lots of people out there who are afraid to fly. If you're one of those people, listen up, because Johnny went to the airport with a NASA engineer who will hopefully allay those flying fears.
Think about it. Nearly every day you probably hop in your car to drive somewhere, right? And I bet you hardly ever think about how dangerous it can actually be. In fact, driving in the US is so dangerous, there are literally millions of accidents every year. So statistically, every one of us will be in a car accident at least once in our lifetime. Now, even knowing how dangerous driving can be, I personally can't think of anyone that's afraid to drive, or at least ride in a car. But what about the fear of flying? Come on, don't you know somebody that's afraid to fly? Huh, yeah. In fact, the fear of flying ranks in the top 5 phobias in the world, right behind fear of snakes. Ugh. But is this fear rational? Well, I can't answer that, but I can tell you that flying is much safer and much greener, thanks to NASA research. Anna, how are you?
Hey, Johnny.
Good to see you.
How's it going? Good to see you.
Good, good. Thank you so much for meeting me out here at the airport.
Sure.
Right off the bat, you know, we hear that flying is safe.
Yes,
How
of course.
safe is flying?
Well, flying is still the safest form of transportation. A lot of people feel safer in their cars, but really, airplanes by far are the safest form of transportation.
Really?
And at NASA, you know, we're not only making the airplane safer, considerably safer, we're also making the airplane more efficient. We are addressing the environmental challenge for aviation.
So how does NASA do their testing? I mean, is it still done in wind tunnels, or?
We do a lot of wind tunnel testing. We also do ground testing for our structures and materials. We actually make panels or parts of airplanes.
Oh, wow.
We shake them to death. We break them sometimes
Really?
on purpose to find out where the breakage points will be. We also do things, we do flight tests. At NASA Dryden, we actually fly, do new technologies of airplanes on current aircraft. to see how they'll perform. We do testing out at our NASA Glenn facility on engines, combustors and turbines, and look at new blades that'll go inside the airplane engines to make sure they're very, very efficient. So we do considerably a lot of testing on the ground, in the sky, and then we also do something in the computers. We create very elaborate mathematical models so that we can predict how things will perform in the computer before they actually happen.
Wow.
So that when someone asks us, how do we know this technology works? We've done the testing in a wind tunnel or a flight test or an engine test, and then we also have a mathematical model that simulates that performance the same way that it happened in the lab.
Really?
So that we can use our math tools to design new technologies accurately and predict what their performance will be.
All right, so growing up as a kid, I grew up kind of near an airport. Yeah, lots of noise.
Right,
Yeah.
right.
Are we doing anything about this?
Oh, yes. Noise reduction is a part of the environmental challenge we really have. We want to, airplanes are so vital to our economy, we have to keep flying, and we're going to increase the number of airplanes that are flying. But we cannot increase the amount of noise that we create.
Okay.
So we are developing technologies for the airframe, the airplane itself, as well as the engine to reduce how much noise that's been created. A long-term goal is to contain all the noise the airplane creates in the airport boundary. So if you live next to the airport like you did growing up, you won't actually hear the airplanes taking off and landing. This involves technology within the engine, believe it or not, and as well as on the outside of the engine, on the cowling of the engine. In fact, we created something working with Boeing and many other partners called chevrons. They look like little teeth on the back end of the engine, and those actually reduce the noise that the engine creates. Then on the airplane itself, we're looking at how you can change parts of the wings, the front end, we call the leading edge, as well as the back edge, the trailing edge of the wing, so we can smooth it out so there's less edges, so we create quieter flight. Wow. And we're looking at reducing the noise, even at the landing gear create noise, so you wouldn't even think. Our challenges today are to make the airplane even safer than they are today, so we reduce the mishaps and any problems that we have on airplanes.
Sure.
But also our goals for environmental conservancy are huge. We want to reduce how much fuel the airplane uses by 40% and in the long term 70%. Wow. You're not getting a 70% reduction in how much fuel the airplane burns by using today's technology.
True.
So we have to bring in new technology to make the airplane even lighter than it is today without sacrificing safety and in fact improving safety while we're doing it.
Anna, thank you so much for everything.
Thanks a bunch, it was great.
It was a lot of fun today.
Thanks.
Definitely. And guys, so anybody out there that's afraid of flying, don't be. You heard what she had to say, right?
For Johnny Alonso, I'm Jennifer Pulley. Catch you next time on NASA 360.
We're going to understand how they perform. We're going to make those technologies ready for tomorrow.
Check it out. Now we're at the races.
So if you hit the ground like this, it's going to offer lots of protection, right? Oh, well. And that was not sheer, that's just, yeah, so.
But researchers also need to see this craft fly in the real world. And what better place to do it than where the, guy's like waving over, all right.
And we're also going to see how NASA is flying. Yeah. Sorry, we're not supposed to see that.
Tom, I don't think we need that page. We're good.